Greetings, everyone. Through here. Welcome to the Demo Hub. Today, we have a fascinating demo with a tool called Sematic. Sematic is an open source machine learning platform built to automate recurrent end to end machine learning processes, regression testing, and continuous performance. Emmanuel, welcome to the show.
Yeah, thank you so much for having me, Fru.
Really glad to have you. Where are you calling from?
I live in Oakland, California, so the Bay Area.
You must have a nice weather there at this time of the year.
Yes. Actually, the winter was pretty rainy, but right now it's sunny, so we're glad.
Excellent. I'm out in the Midwest looking out the window this time of the year. It's a little bit rainy, but we can deal with it. So excited to have you. Sematic has come across the radar for Demo Hub. Glad you can join us. For the audience that haven't heard about Sematic, can you give the elevator pitch, orient around what it is and where it falls within the modern data stack?
Yeah, for sure. So Sematic is built by a team of ex-Cruise engineers. So Cruise is a self-driving car company out here in San Francisco. So they run robotaxis around San Francisco, also Austin, I think, and Houston and Dallas as well. And so we're a team of 5 ex-Cruise engineers. So we built the machine learning infrastructure for Cruise. So as you can imagine, Cruise has a lot of machine learning models running on the cars all the time for object detection, tracking, segmentation, and so on. And so those models need to be retrained quite often. Every time there is new data that is being labeled by the labeling workforce, the models need to be retrained. So that means processing data, training, evaluation, extracting metrics, and so on. Being able to do this automatically and get the metrics as quickly as possible requires a lot of orchestration. So basically, you need to orchestrate jobs that run on different backends. For example, a data processing job that would run on like a Spark backend, for example, or a PyTorch job that runs on a GPU backend, and so on. So Sematic is an orchestration platform that lets ML engineers build DAGs, so graphs of operations, to construct end-to-end pipeline. For example, you can start from raw data that is sitting in a data warehouse, so maybe a Snowflake table or Redshift or whichever you're using, and executing the pipeline on that data, converting the data, training the model, and so on, to get to a final product, which would be your model, maybe a deployed model or some metrics to decide whether you want to deploy your model in production. So Sematic enables you to very easily build those pipelines of sequential steps and run them on your local machine, but also in your cloud cluster to have access to cloud resources. So we know that it is very difficult to run jobs on cloud resources. So we make it extremely easy just by using Python, and I'll show you later, to do this without having to know anything about infrastructure.
Oh, that's excellent. And machine learning, ML ops is something the industry is really talking a lot about these days. So having a tool that does that end-to-end processing is very fascinating. Now, maybe just from an orientation perspective again, just to help understand, if we think about ML ops and those like the ML flows of the world, are these more on the competitive side to what Sematic does, complementary? Maybe just touch a little bit on that and what the differences are.
Yeah, so it's more complementary to MLflow. So MLflow is good at 2 things from what I've heard and also from my usage. It's good at model tracking. So you can register models and then compare metrics between different models, and then model serving. So if you want to put your model behind an API endpoint to send features and get inferences back. For the actual execution of the training pipeline, it's fairly limited. It does have a little bit of pipeline functionality, but it's very simplistic. It doesn't really allow you to leverage really large cloud resources like GPU clusters and so on. The pipelines that our customers have typically run for multiple hours, sometimes multiple days, because they have to train deep learning models on GPU clusters. And for that, you need a framework that sort of enables things like fault tolerance, retries, and things like that. So basically heavier duty workloads than MLflow. If you want to compare Sematic with the competition, the very old incumbent is Airflow. I'm sure your audience has heard of Airflow coming out of Airbnb maybe 10 years ago. And Airflow was originally designed for data pipelines, so to sequence SQL scripts. Now it is Python based, but the problem with Airflow is that it is really not suitable for machine learning for a number of reasons. For example, it doesn't allow for iterative development, so you cannot easily change code and then run your pipeline again. You have to deploy it to the Airflow instance. And also it's lacking in areas such as traceability and visualization. So Airflow is an orchestrator, but it's not suitable for machine learning. And so this is where we come in.
Wow. So the airflow for machine learning would be what Sematic is. Is that a
That's
fair
correct.
way to put it, a very descriptive way to put it?
Mhm.
Now, is the product then, are we looking at a SaaS-based solution that has folks can access, or is it more an open source, maybe CLI you can install and run? Can you talk a little bit about the deployment options?
Yeah, for sure. So at this time, Sematic is open source, so anybody is free to install it and run it on their local machine. So pip install Sematic, Sematic start, everything will run locally, the pipelines, the tracking, the web dashboard as well. Obviously, to leverage more of the value that Sematic offers, it's best to deploy it in a cloud environment. So typically on top of a Kubernetes cluster. So some of our users do that. It's very easy. We have a Helm chart to do that. And we don't have yet a SaaS product. We are targeting the end of 2023 to have a fully hosted SaaS product. So currently, our customers deploy Sematic inside their cloud environment, so AWS, GCP, Azure, and whatnot, and then submit jobs to run on those resources.
Excellent. So end of 2023, but the version in PEEP today is accessible that folks can use and be off and
Yeah,
running with.
that's right. So it's open source, pip install Sematic, Sematic start, and also the package ships with a number of example pipelines, so you can have things running without writing any code. We have a couple of examples that are shipped in the wheel.
Excellent. Before we jump into the demo, can you talk about, you did mention integration with different data sources, cloud data warehouses, snowflakes, maybe there's a data lake. Does it actually run and do the computation leveraging, say, the Snowflake compute, or do you access the data from those data platforms to run in your own Kubernetes cluster with the GPUs and the compute within that environment? Can you touch a little bit on that?
Yes, for sure. So as I will show you, Sematic lets you orchestrate arbitrary Python functions. The actual Python functions themselves will run in your Kubernetes cluster. If, as part of a Python function, you are calling the Snowflake API to run a SQL query in Snowflake, then obviously this SQL query will run in the Snowflake compute engine and will return you the output data that then you will be able to consume to train your model. So in terms of data sources, you're free to use whatever you want because it's Python, so you can use the Redshift, e.t.c, the BigQuery, or Snowflake, or whatever you're using. S3 typical. Some of our customers basically store their data on S3, and as part of their Python functions, they will download this data from S3 and then transform it and then store it somewhere else on S3, for example.
Excellent. You mentioned at the beginning a deep technical background from Cruise. Is there a slant or a bias to unstructured data, videos? If I think about Cruise, maybe I'm thinking about computer vision, that as part of that training, you have maybe certain slant to that, or that's not a fair line to draw? Oh,
Yes, product itself is agnostic to the type of machine learning that you're
mhm,
doing. So you could be doing things, XGBoost, scikit-learn, PyTorch, TensorFlow. You could be doing
mhm.
computer vision. You can be doing LLM fine tuning. It's really up to you. It's up to you to decide where to store your data, how to stream it, what APIs to use, and so on. We're not sort of focusing on any particular use case. It is true that at this time, our customers are mostly in the computer vision space. So think about robotics companies or autonomous driving companies because they are the ones who typically need large resources, so GPU clusters, for example. And so this is where we are the most helpful. But we also have use cases of people running more lightweight data science workflows and benefit from the traceability and visualization capability of the product.
Excellent. So really excited. If you have the demo, we can jump in and for show for the audience how they can access Sematic and get started. So
All right. So let's focus here on the left side. So as I mentioned, Sematic orchestrate Python functions. So it lets you build a pipeline of Python steps, and those steps are defined as Python function. For example, here I have a very standard Python function that is using PyTorch code to train a model. In this case, this is the MNIST model, which is the hello world of computer vision. It's very simple. So none of this code is anything specific to Sematic. It's just regular Python code that takes in a training configuration, a data loader, some PyTorch device settings here, and then trains the model and returns the trained model. Now, what I have done to convert this function into a pipeline step is I have decorated it with the Sematic decorator at Sematic.func. And this will turn this function into a pipeline step that is tracked and visualizable in the dashboard that I will show you in a minute. Also, I have passed some settings here. Most notably, I have passed this setting here that says that I want this function to have access to GPU resources. So as I mentioned, we're trying to abstract infrastructure. So users know that this workload, this training workload needs GPUs, but they don't want to have to care about where do I find those? How do I allocate those machines in the Kubernetes cluster? So they're passing those resource requirements here where we're requesting 2 CPUs, 4 gigabytes of memory, and a GPU. Now, once I have this single pipeline step, I can create another one and chain them together. For example, this is the evaluation step. So this one takes as input the model that we trained in the step that we showed just before, the test data loader, and again, some PyTorch settings, and is evaluating the model and returning some evaluation results. So here I'm returning some metrics and also a couple of figures, so like a PR curve and a confusion matrix. Now I have 2 individual steps here. I have train model and evaluate model. Now I want to chain them together in a small pipeline. So here I have another function that is doing train eval, and I was going to call train model, get the model back, and pass it to evaluate model here, and then get the evaluation results and return those. And so this is just simply another Python function that also has been decorated. Now I can include this sub pipeline in a greater end-to-end pipeline, which is what I have down here. So as you can see, it's just another function that's been decorated with the Sematic decorator. And here I am loading a train data set. This is loading the test data sets, preparing the PyTorch data loaders, and then passing this to the train eval function that we saw just before. So as you can see, with just some very simple Python code, I was able to define the steps in the pipeline and then stitch them together. So many other pipelining tools will require you to write a YAML file, for example, to define the structure of the pipeline, the DAG, the sequence of operations. In our case, we are using native Python to define this flow of data between the steps of the pipeline. And this is great because it allows you to use just regular Python stuff like looping or conditionals, if, then, and so on, to have a dynamic graph. Now, let me show you how this pipeline looks like in the dashboard. So
yeah, just a question, and then we're going to jump into the dashboard. If you want to scroll up to the very top of the code here, I'm guessing you're importing some Sematic packages you've installed that with pip. Now that's accessible
Correct.
for use as part of the decorator, and now you decorate your functions, and essentially you're building a DAG.
That's right. That's correct. So
that
Sematic is a Python wheel. So you pip install Sematic, and then there's an SDK that comes with it. So import Sematic, and then you import a bunch of APIs that we use to configure those functions, and also comes with a command line interface, so a CLI, to execute those pipelines. And I'll show you now how this works. And also comes with this UI that you see here on the right. So here I have a list of the pipelines that I've executed in the past. So for example, here I have my mlist example. So I can click on it to see the last details of the execution of this pipeline. So before going into details here, I'm going to show you the execution graph. So here, this is the DAG of the pipeline. Each of those boxes correspond to a Python function that we've defined in the code. For example, here we have our train model function that we had defined down here. So here we have train model, evaluate model, and then as we did in the train eval function, here we are chaining those together. So the output of train model is being fed into the evaluation step here. And then I have this train eval sub pipeline that basically is being orchestrated with the rest of the end-to-end pipeline here. So this is the actual data flow of the artifacts between the different steps in the pipeline. Now I can click on any of those to visualize the inputs and outputs of any step. So for example, if I click here on evaluate model, it's going to open the details for this particular step. So I can take a look at first the source code for this step to make sure that I'm running the correct code. So this is exactly what we saw in the editor and in VS Code on the left. I can take a look at the inputs for this function. So this is my train model. These are the details of my test data sets, the batch size, and so on. And here I was running using the CUDA device for access to GPUs. And then I can take a look at the output of this function. So as we saw in the code, we are outputting a number of metrics here, the accuracy of the model, average loss, also a plotly figure, which is this confusion matrix, a PR curve, and so on. So as you can see, Sematic extracts and persists all of the inputs and outputs of each of those functions for traceability and visualizations. So I don't have to persist those plots myself by hand somewhere on the cloud and then download them locally to visualize them. It's all taken care of natively by Sematic. So,
Excellent.
right. So I can show you now how to run this. So you can run this code on your local machine. So I'm going to run it now. Let me expand this terminal here. So this is going to run locally. So obviously it might be a little slower because it's not leveraging. So there you go. We have a new run here. So I'm going to open it and take a look at, so the pipeline is being executing now. As you can see, it's all running on my local machine here. So this is typically users will execute on their local machine with a smaller amount of data to iterate, debug, make sure that everything looks good. And when they're ready to execute at scale, they will launch the job on the remote cluster. And I will show you how this is done as soon as this has completed. So as you can see right now, we're in the train model step. And so, yeah, right here we have the logs. It's basically training a single epoch of the model, and it's proceeding, and we will have results in a few seconds. So while this is running, right after this, I will show you how to submit the same code without any code changes to run in the Kubernetes cluster. And what is great about Sematic is that it takes care of dependency packaging. One thing that is really hard when you want to run a job on a remote service, like a GPU cluster, for example, is that you have to build a container image in which all your dependencies are available. So that includes your pip dependencies, your own user code, any static libraries, your CUDA drivers for your GPUs, and so on. So you have to build Docker images. It often fails. It's often very flaky. Okay, execution has completed. As you can see, it's all green, and I can take a look at results. And these are the outputs of the pipeline. And so this looks pretty good. So I'm going to leave a note here for my coworker. Looks great. Let's try with more data. And there you go. So now that we've run this locally, I'm going to submit this to run in the cloud on more epochs to see how you can easily scale. So here I'm essentially just telling the Sematic command line to actually also build a Docker image at runtime to submit my local environment to the remote cluster. So here I'm submitting the same code, but to run remotely. So this is going to take a bit more time to package. Here, this is building a Docker image right now, including the local code, my third-party dependencies, so all the wheels like PyTorch and so on that are needed, and also building this on top of a CUDA-based image so that it can run in the cloud. So this is building right now. It's going to take a few minutes to build the image and then submit it to run in the cloud. So this is roughly how the product works. Users will develop their pipeline in Python, iterate on them on their local machine, and when they're ready to run it at scale, they will simply use a different CLI arguments to submit the same code to run in the cloud.
Excellent. Very, very powerful to go through this. A couple of things I wanted to touch on here as we're going through. So this is from a Visual Studio Code experience. For full transparency, haven't been a data scientist, but do have some ideas of what data scientists do. I do understand some of them work with notebooks, and like your Jupyter Labs, and there are many notebook flavors out there. How do you see that integrating or not with a workflow like this?
Yeah, for sure. So notebooks are obviously very powerful tools that are used by ML engineers. So in general, we come right after users have completed their work in a notebook. So typically notebooks are good for prototyping, to do a kind of small version of the model, because you're usually running this notebook on your local machine or on a small VM. And so what we're trying to do is to get people, once they have a prototype working in a notebook, they need to productionize the training pipeline so that it can be repeatable, that it can be reviewed by other people in the team, and it can be automated to run on cloud resources. So we're trying to get people, when they're done with the notebook, to export their code into Python modules and build this pipeline as a kind of an application.
Yep.
Of course, they would still be able to use Sematic inside a notebook if they so wish. But the ideal use case is, once you have your notebook, like, okay, this model looks good. I want to run it on a much larger amount of data, and I want to productionize it so that I can run it, maybe on a weekly basis. In that case, I'm going to step out of the notebook and start writing Python code in Python modules directly.
Excellent. And you do have a very powerful collaborative aspect to this. Once it's made it to the UI and folks can collaborate and leave comments, can you touch a little bit about the collaborative dimension to this and how that really transforms the workflow of your data scientists or your ML engineers during that training and development lifecycle?
Yeah, for sure. So what we've seen in the companies where we worked at, so at Cruise before and before Cruise, I was at Instacart, is that users will typically, download plots into their local machine and put them in, Excel spreadsheets or Google Docs, and then share them on Slack and so on. And so a lot of context is lost. Okay, this plot looks good, but what is the job that produced it? What data was used? What settings, what configurations were used? What resources, what type of GPUs were used? So that there's a context that is being lost by extracting those plots from the platform where they were generated and sharing them on Slack. So this lineage of the kind of assets that were used to create these plots are lost. So we're trying to bridge this a little bit by having this chat section here. In the future, we want to integrate this more closely with Slack so that when you post a message here, it also posts on Slack, and then people can respond on Slack, and it responds here very much like comments on Google Docs. The point is to keep always a full knowledge graph of all the information from the actual data that was used to train the model, the configuration, the output, and the actual human comments on that, on those results. We're trying to keep this a consistent knowledge graph so that there is no loss of information in the process.
Excellent. So just going back again, the airflow for machine learning, I think that really oriented this for me coming in very, very clearly. Now, on the technical side, you went through the install, it's pip install, but there is a lot of metadata that's generated and persistent, and you're leveraging that for the UI. Where is that? Where is that being stored? Is there some RDBMS behind the scenes being used for this, or is it just using SQLite or flat files? Like, where is that being stored from the app perspective?
For sure. So if you're using Sematic entirely locally, so pip install Sematic start, then everything runs on your machine, including the metadata server. So it's like a REST API where we post all this metadata. Also, the UI is running on your local machine, and we are storing your metadata in a SQLite database on your hard drive. This is the entire local experience. Now, if you want to leverage cloud resources, so in this case, this UI here is deployed in a Kubernetes cluster. So in that case, we leverage a Postgres database to store the metadata of the pipeline. So all the run statuses, all the summaries of artifacts that we show in here is in a Postgres database. And we persist the actual artifacts in S3 or in your cloud storage, whether it's S3 or GCS, depending on where you're deploying it. So we persist a source of truth of all the artifacts because we guarantee reproducibility of your pipeline. Once your pipeline is completed, you can rerun it again with different inputs, for example. And so we guarantee that all the artifacts that are necessary to execute your pipeline, so that includes the code itself, so the container image, the Docker image that was used to run the pipeline, all the input artifacts that were used are persisted as source of truth, so that if you have an issue with a model in production, let's say you deploy models to production, you start generating inferences that you serve in your product, for example, and you see an issue, you need to debug what's going on. Okay, why is the model failing? Why? And so you need to know what data was used for this. So the model ID that you used to ship to your model to production, you can go back and find in this database, okay, this is the model that was used. This is the job that generated the model. And these are the inputs to that job. So we persist all of this as a full sort of lineage tracking of all the assets that went into training your model.
Oh, okay, excellent. And I'm guessing as you're thinking about the SaaS version for organizations that might be more security conscious, maybe in more regulated spaces, to where they could bring their own RDBMS to persist that metadata on the backside. Is that kind of the vision?
So the reason why we haven't gone to SaaS directly is because many of our customers have very sensitive data. They have very private data, or it's data that is very proprietary. And so they don't want this data to leave their VPC. It's typically maybe sometimes, images or videos that are being stored on S3, and they don't want this data to leave, which is why we've decided first to deploy on-prem. So we deploy inside their own infrastructure. So their data does not leave their infrastructure. It's still within their VPC. So we're typically streaming, for example, from their S3 bucket into their Kubernetes cluster. In that case, there is no concern in terms of privacy. For the SaaS product, I believe that it will work mostly for people that are okay with their data leaving their VPC. So for example, if your data is in Snowflake, the way you access Snowflake is already through a cloud API. And so you already have data that is kind of traveling over the public internet. And so in that case, the SaaS product will be suitable for you. If you have very big concerns about the privacy of your data and you don't want it to travel over the public internet, then it's best to deploy Sematic on-prem in your Kubernetes cluster. And we make that very easily with a Helm chart. It's like a couple of lines to launch it. And so this is how we deal with data.
With that, all right, excellent. So can you touch a little bit on the integrations that are available with Sematic in terms of thinking of maybe a data catalog? Because now being the airflow for machine learning, are you emitting some of this metadata to plug into data catalogs that could build a lineage from source transformations yet? Or is that something that the team is thinking about?
So as I mentioned, when we deploy Sematic
Mm,
in somebody's cloud infrastructure, we store all the metadata in a
mm,
Postgres database. What we've seen our customers do is that typically they will export this Postgres database into their own data warehouse to correlate this information with the rest of their
excellent.
tool. Every company has different tools. Maybe it's
Mhm,
Buildkite, Circle CI. Maybe they have some Tableau dashboard and so on. And so
excellent.
it's hard for us to know exactly what they need. Every
Mhm,
customer has different use case. So this Postgres database, they can export it and correlate information with the rest of their data. One thing that we do is we have a metrics API for users to, as I showed right here. For example, here we have metrics on every pipeline, number of runs, success rate, average runtime, and so on.
mhm.
In the near future, we will also publish this information to Prometheus so that anybody that is running Prometheus, the observability tool, will also be able to have those metrics available in there and then use things like Grafana, for example, to have performance metrics on their pipelines. And a success rate is a very important one, for example, because a lot of people use Sematic to do regression testing. So for example, if you have a CI pipeline on Buildkite, as part of your CI pipeline, you could be submitting a Sematic pipeline for like a model training job, for example. And so you need to have the kind of this pass fail information to be given back to Buildkite to know whether your code is ready to ship or not.
Very, very, very powerful. Emmanuel, this is excellent. Maybe we bring this back a little bit and talk about the vision. I
Mhm.
think this is something that's exciting to you. It's you're pouring a lot of energy into this. It definitely seems to solve a problem and fill a space where there's definitely a gap. What is the holy grail? What is that next step as you're envisioning that? And talk about what teams are either missing today and also maybe your vision as overall in the next year, 2, 3, 4, 5, once this all materializes and teams have that at your fingertips with Sematic.
Yeah, for sure. So what we've seen in the industry is that a lot of companies will definitely produce machine learning models, whether it's for computer vision or their sales funnel optimization or forecasting sales or things like that. But typically, they will train the model once, for example, in a notebook, and put it in production, and then never touch it. The problem is that models are not static assets; they constantly need to be retrained with new data because the underlying data changes. For example, when COVID happened, many consumer patterns changed overnight. People stayed more at home, ordered more online, and so on. So many machine learning models that companies were using were suddenly ineffective predicting their customers' behavior. And that the reason why they were not able to catch up quickly is because they were not retraining their model often with frequent data. So we're trying to encourage all companies that are doing machine learning to think about the continuous machine learning aspect, that all models that are being used in production need to be retrained very often. Let me give you an example of what we saw at Cruise. So, Cruise has a lot of models on the car, obviously. Those models are very performant, obviously. Otherwise, the Cruise cars would not be able to work. However, sometimes those models have an issue. They will brake a little bit too late or have a swerve around an obstacle and so on. So it's important to identify those moments where the models did not perform well. So that applies to self-driving cars, but applies to any other models in production. So do some data mining on those inferences to figure out when did the model fail, and then sending those instances to their labeling service to get what should the model have predicted if it had not failed, and then add those examples to their training data sets so that they can retrain the model. And so the models learns in the long tail of events that it had not seen in the original training data set. So this is important. It's important to do this on a regular basis. To have this entire loop that is automated, where you ship a model, you persist inferences, you mine for errors, you label errors, and you augment your training data set. Otherwise, models will never improve, and also will never pick up on new trends of user behaviors out there. And this is only possible if companies build those end-to-end pipelines with a single click, with a single command, CLI command. You should be able to refresh your model with new data. So, and that takes a lot of infrastructure because there's many steps that are involved in training a model: data processing, training, evaluation, metrics extraction, and so on. So we're trying to move people from a very manual workflow where, oh, I'm going to just refresh my notebook and ship my model to production after that, to a much more automated workflow where they have those end-to-end pipelines that are ready to be re-executed every time there is new data. So this is our vision for the product. Now, in terms of Sematic itself, as we discussed, we're aiming to launch a SaaS product by the end of the year to give access to more people to this tool. One of our key elements of our vision is to remove infrastructure headaches for ML engineers. ML engineers typically have masters or PhDs in computer vision, statistics, math. And so infrastructure is a bit of a foreign concept to them. Knowing how to deploy a job on a Kubernetes cluster, how to debug container jobs, it is pretty hard. So we're trying to make this a lot easier and make them autonomous at doing those tasks without having to ask for help from infrastructure teams. So we're trying to empower the ML workforce to be autonomous and not require so much help from infrastructure folks. So this is our vision for the next 2 to 5 years.
Yeah, that's definitely a very powerful vision. And you elaborated there on the whole issue of model drift, right? The model that used to work 6 months ago for predicting customer behavior, it's not going to work today if you don't go keep the model up to date with constant training and constant data. And that was a good segue to a question, which is, assuming with new data coming in, are there APIs that are exposed to say, well, we've got a new data set that's landed in Snowflake or in the data lake, let's trigger a retraining job? I'm guessing that there are APIs that are exposed to trigger the pipelines or the DAG from within Sematic. Is that correct?
That's right. So at this time, users can either use our REST API to trigger the re-execution of a pipeline. They can also use the CLI. So for example, if it's being triggered by a CI job, they can just simply use the CLI, as I showed in the example. In the future, we'll also provide abilities to schedule a pipeline, for example, to run with as a cron schedule, maybe every Monday at 8 a.m., for example. We'll also provide functionality to trigger based on events like a PubSub event, for example, or a Kafka event or something like that. Or, and this is kind of the holy grail, to trigger pipelines automatically on data changes. So for example, you could say, every time this table has 10,000 new rows, run this pipeline again. And we want to provide this functionality probably in the next couple of years.
Excellent. And would you look to stay more just within that training pipeline, or would you want to extend your tentacles into model management and versioning and scheme and registry and all of that? It's okay if that's not the ambition, but just curious.
Yeah, so we already have this artifact store. So as I mentioned, every input and output of every pipeline step is being persisted. That means that all models also get an artifact ID. And so at this time, we don't have any particular interface, for example, to list models or compare them. But we do want to add the ability soon to select a number of artifacts. So maybe select 2, 3, 5 models and compare their metrics directly in the UI. So that's something we want to add in the near future. But also, we are very aware that there are many other tools out there to do that. For example, you have things like weights and biases is one. Comet ML is more on the experiment tracking side as well. And so we don't want necessarily to reinvent the wheel. We would rather users integrate with those tools rather than us trying to replace them.
Yeah, weights and biases. I think you mentioned that Iguazu, GVC, there's a very active space there. Last question would be about pricing, because obviously there's an open source aspect to this, but you're probably not running a charity here. So can you talk about the go-to-market and the pricing today, or what you envision in terms of how customers will access it? Is it by seat, consumption? Just elaborate a little bit on that.
Yeah, so at this time, we mostly sell on-prem, as I mentioned. So we sell enterprise licenses on-prem. So you see usually a yearly license that we sell to our customers, and we charge per seat. The actual dollar amount per seat depends on the company and depends on how much support they need from us and so on. So it's not a fixed price. However, when we launch the SaaS products by the end of the year, we will charge per usage. So not necessarily per seat, but per usage. So for example, per GPU hours, CPU hours, and so on. We haven't nailed the exact pricing yet. However, we're trying to be very competitive so that we don't add too much on top of the raw compute, because people are going to come in and be like, oh, I pay this much per minute of GPU on AWS. I don't want to pay much more for Sematic. So we're looking into ways to make lots of gains and savings on GPUs and carry that out to our users as well.
Wow, that's excellent. Now, and this is great. Thank you so much for going through this, for the orientation around this. I'm guessing users watching this might have more questions. They might want to go deeper. You definitely have lots of angles you could take this. How could users find Emmanuel? I'm guessing you're on social media, or the company as a whole. Are there any links, Slack channels you want to call out for the audience?
Yeah, for sure. So to find our landing page is simply Sematic.Dev. So it's Sematic.Dev. Once they're there, they can easily join our Discord channel. So we have a Discord channel with all of our open source users. So they can join there to ask questions, report bugs, or even if they want to contribute to the product, it's open source. So we're always welcoming new contributions. They can reach out on there. Also, they can find our GitHub repo from our landing page. And we always are looking for more GitHub stars because we're open source. So please, people, get on Sematic.dev, click on the button to start the repo. And also on this GitHub repo, we have a list of issues that are suitable for first-time contributors. So if you're interested in contributing in open source, we have a number of issues. I think there's about 15 open at this time, where it's sufficiently easy for a first-timer to get started. So getting there, and also get in touch if you need more information.
That's excellent. And we're gonna leave links to all of that in the description below for folks that wanna check it out. Before we sign out, can you touch about the name Sematic? That keep just ringing through my head. What is there a meaning behind that? Is there some background to Sematic? If you could talk on that a little bit.
Yeah, for sure. So what I've learned from years of working in the tech industry is that you spend a lot of time looking for a name, and once you find it, you love it, and then 3 weeks later, you start hating it. So my point is, when we started the company, we decided to time box the search for a name to one afternoon, and so we started looking at all the domains available and so on. And Sematic was a good one because it's a mix between semantic and automatic. And let me explain what I mean by those two words. Semantic, because the product adds a semantic layer on top of orchestration. You can have all this information that I showed in the dashboard, all those inputs and outputs of all the steps, the plots, the metrics, and so on, adds a lot more meaning to your jobs than just here's the command line that was run, here's the logs of the job, and so on. So there's a semantic layer on top of orchestration. And automatic is a bit more obvious, is because we're trying to automate as much as possible of the machine learning workflows. So Sematic is a mix between semantic and automatic.
Excellent. It definitely has a good ring to it. So I think you guys did a good job that afternoon of coming up with names. So, well, Emmanuel, thank you so much for coming. It's always illuminating talking to founders and builders in the modern data space. It's an active space. Machine learning, as you know, AI is literally eating the world, as people say. So, really great to see this product. And we're going to leave links to all of this for folks who want to reach out to you, to your team. You're not just building a product, you're also building a community. So we're going to leave links to all of that in the description below. So thanks again for coming on board the Demo Hub.
Yeah, thank you so much for having me, Fru.